using the three-force theorem in solving statics problems. This is lesson number 2.3 from the book Mechanical Systems Calculations of the Marine Facilities. Three-force theorem. If a mechanical body in balance under action of three non-parallel forces, then all three of the forces lie in the same plane and their lines of action intersect at one point. As a three-force theorem, we can use to decide the issues of statics. We consider the mechanical system. This is an exercise. A two-body system is assigned in the exercise. The two-body systems indicated on the draft 2.3.1. The body consists of two parts, two disks, two non-changeable parts of the mechanical system, disks A, F, C, and C, and the left and the right triangular parts. The mechanical system loaded by the force F acting on the left part of the mechanical system. The force is 10 kilonewton. And it is assigned to find the reactions of the supports A and B. We can do that using the three forces theorem. And if mechanical system is in balance, that's why the forces acting on the mechanical body are in the same plane and intersect the line of the actions of forces intersect in one point. The analytical method we can use to define the conditional balance of the mechanical system. This system we say arch consists of two semi-arch or half arch, two half arches. When we use the analytical method, so we have to do the balance equations. The balance equations, it could be for the flat state if the forces are in the flat. So the projections of forces on the abscissa axis equal to 0, and the projection of all forces on ordinate axis equal to 0. And the moment of one of the arbitrary points have to be equal to 0, a resultant moment. We, besides that, can consider the parts of the arch separately, the left part and the right part. And the equation of balance of half an arch, I mean the right one half of arch, on the draft 2.3.2b have the balance equations. For example, one balance equation, the total of moment rotating this half arch relative to C point have to be equal to 0. We can use as well the graphic analytical method to decide the issue. And we consider two half arches, the left one, the right one, half arches. And for each of the parts, each one is in the balance state. We have to define that the flat system of forces is convergent. Two flat systems of forces are convergent for both two half arches. Besides, we have to use the axiom of two forces, RB equal to RC. So if for the right one half of arch, we have action of the force RC, for example, acting along the segment of this frame CB. And this force acts on the segment CB, but not for other segments of the half arch. This is, and it predetermined the RB equal to CB. So the tension of force R stroke C transmitted by this segment CB to point B, and we have direction RB equivalent to RC stroke. And in the hinge C, so these two semi-arches connected in the hinge C in the axiom of equality of reaction and action of forces, RC stroke equal to RC. So but they are equal in the magnitude, but opposite of in the directions. So the force RC is opposite in the direction to RC stroke. Besides, we can do the convergent force triangle. It generally could be a polygon, but we have three forces, so it would be triangle. So the force F we can put in the as a hypotenuse of the polygon. At the angles of these half arches, each of angles is 45 degrees. So the legs of this right angle triangle is RC and RA. And this we consider the left half arch. So we do not need to do the projection of forces on the coordinate axis due to the graphical analytical method of decision of the issue. This is not required. We can do only the polygon of forces acting on the left one half arch. And for that, to be in the balance of the left one part of the mechanical system, we can find that the forces, the force RA have to be equal to F, force F, product of magnitude force F by cosine 45 degree. So we can find for the left one that RA is 10 multiplied square root of 2 divided by 2 kilonewton. But if in the next we can use a little bit from the analytical, so we use the graphical analytical approach of decision of the issue, so we can use a little bit about the balance equations, which balance equations which are more characteristic for the analytical issue, and we can consider the projection of all forces, second equation of the balance on the we consider all mechanical system, but not the left and right parts, but all the mechanical system, and the projection of all forces acting on the mechanical system equal to 0. This is forces as force F, force RA, force RB, and this projection consists of force F, but projection force F on the ordinate axis is 0 because force F is perpendicular to the axis of Y. And so only we have the force RA and we have force RB, and we can see that these two forces have to be equal in magnitude due to the both inclined for 45 degrees to any of the axes, but for definite one case relative the axis of ordinata forces R and B are inclined to 45 degrees, and the projections of them are opposite in size equal in the magnitude, and that's why the force RB magnitude equal as well 10 equal product 10 by square root of 2 divided by 2 kilonewton. Questions and comments. Three-fourths theorem with the mechanical body, mechanical system is in the balance. That's why the forces acting this mechanical system, if the forces acting on the mechanical system are in the one plane, so we consider the plane state of the forces action on the mechanical body. That's why the forces intersect in the one point. These three forces intersect in one point, the lines of actions of these three forces. Analytical and graphic analytical methods of solving the equations of forces balance on a plane. For analytical method, we have to consider the balance equations of forces action and the projection equality to zero for the convergent system of forces with not the balance equation of the equality of rotating moment to zero. It's not required, but the projection of the forces on abscissa and ordinate axis. And the balance equations we have to decide, and it will be the analytical decision. The graphic analytical, we have to do the polygon is a consequent addition of each of the forces acting on the mechanical system. For three forces, it will be the polygon will be a triangle of vector forces, and after the geometric mathematical transforms of these forces within the polygon, we can find any unknown vectors and forces magnitudes acting on the mechanical body in the balance. The axiom about two forces. If two forces act along one segment of the mechanical system, that's why the all tension is in this segment and not in other segments of this mechanical system. If the mechanical system exactly hinged, if all connections of all segments of mechanical system hinged, this is characteristic for the trusses. As axiom of equality of reaction and action of forces. In each of hinges, we consider the axiom of equality of action and reaction of forces. If any force acts in the hinge, that's why the hinge is in the balance. That's why there is the reaction of the same magnitude and the opposite direction with the action forces. Thank you very much.